Hello, friends. Welcome to Science Talk. I'm your host and resident oceanographer, Jim Hassel. I want to share with you a series of animations from the NASA website where they examine possible factors causing the observed warming that we have data for. So, let's start with this first one here. There's a series of about 12 such little graphics here. Skeptics of man-made climate change offer various natural causes to explain why the Earth has warmed 1.4 degrees Fahrenheit since 1880. They're now saying 1.4. It used to be 1.1. That's, of course, degrees C. Oh, excuse me, 1.4 Fahrenheit. That's actually should be 1.4 Celsius. They use Celsius, so that's a little bit of an error. I didn't catch that before. But can these account for the planet's rising temperature? Well, let's take a look at the first graphic. So there's you observe. Okay, so there's the observed temperature, and this would be a baseline average here, this horizontal line. Going above it is to hotter conditions, going below it is to colder, cooler conditions. Okay? So as you can see, it started at about 1880 or so. Let's take that back, right? 1880, up to this one runs to 2014. So that's the observed. So, is it the Earth's orbit? Earth wobbles on its axis. Its tilt and orbit change over many thousands of years. This is the Milankovitch cycle. I did a lengthy video discussing that. Pushing the climate into and out of ice ages. Yet the influence of orbital changes on the planet's temperature over 125 years has been negligible. Okay? So again, we're starting 1880. Where I paused the graphic here is the year 1901. So let's continue this. So now, as you can see, let's take a look at some interesting things here. If orbital changes were affecting the climate, see how this is below the average? That means this observed value should also be below the average. In other words, this is telling us that if orbital changes were causing the observed changes, they should track closely together. They're not. Where we would see, if you look at for the great majority of this graphic here, it should be on the cooler side. The Milankovitch should be leading us into cooler conditions. But look at the observed. It is warmer than usual. I said that in some ways, because Milankovitch would have us go into a cooler situation, it kind of has alleviated how bad things could really be. Imagine if Milankovitch was taking us into warmer conditions. You would have the orange line above the horizontal line, but then the observed might be even higher up. Okay. So as this graphic shows, it's negligible. Is it the sun? Okay. The sun's temperature varies over decades and centuries. These changes have had little effect on Earth's overall climate. So you get people saying, oh, it's the sun output. Nope, not doing it. It is not. In fact, depending on which studies you look at, the contribution of solar insolation to affecting the climate is, depending on which studies, anywhere from about 4, 5%, 7%, maybe up to 11%. I think that's the highest I've seen. Usually it's around 5 to 7%, which means that it's only accounting for 5 to 7% of the variation seen, which is not much. It is not significantly significant. So we let that run out. Again, you can see overall, it's not affecting. Is it volcanoes? The data suggests no. Human industry emits about 100 times more CO2 than volcanic activity, and eruptions release sulfate chemical that can actually cool the atmosphere for a year or two. And we're talking, 1850, 1880, we were talking 140 to 170 years. I just did a recent video where I discussed human emissions versus volcanic emissions as to which one impacts the climate more so. And spoiler alert, it's humans. So let's look at how volcanic. Now, I want to pause it here. It looks like there's a pretty good correlation right in this little time frame, but then it kind of, let this run out, it kind of then does not track well. So, see what else. So, is it all three of these things combined? If it were, then the response to natural factors should match the observed temperature, right? This white line is the observed temperature. Adding the natural factors together just doesn't add up. So what they're going to do is they're going to run the three graphs before, and then they're going to run the summation. So first one is the orbital changes. Here comes the solar. Here comes the volcanic. I'm going to let that run through. And now we're going to graphically add this and natural variations in this kind of yellowish, pale yellowish. As you can see, it not affecting what we observe. So what these show us is that natural factors, natural parameters, does not impact the warming that we're seeing. That is, a couple sentence summation of what we've just been looking at. Let's continue. So if it's not nature, is it deforestation? Humans have cut, plowed, paved more than half the Earth's land surface. Dark forests are yielding to lighter patches, which reflect more sunlight and have a slight cooling effect. Darker the leaves, right? It comes back down to albedo. If I have a dark leaf and a light leaf presenting itself to the sun, the dark leaf absorbs more energy. The light leaf reflects more energy. So we're seeing more lightly because the trees are younger. So we would expect increased albedo to cool things down. So the green graph is land use, and let's see what happens. Not really a good explanation, is it? What about ozone pollution? Natural ozone high in the atmosphere blocks harmful sunlight and cools things slightly. Closer to the Earth, it created by pollution called smog and traps heat, making the climate a bit hotter. Overall effect, not much. Here we go. Here we're running it. You notice when we get to about the late 60s or early mid 70s is when things really begin to diverge. It's like all the cumulative effect is now beginning to kick into place, kick into gear, and take off. And like everything else, this here are seasonal variations. How about aerosol pollution? Some pollutants cool the atmosphere, like sulfate aerosols from coal burning. These aerosols offset some of the warning. Unfortunately, they also cause acid rain. Yes, if you have sulfur dioxide, you mix it with water, you get sulfurous acid. Okay, so not hydrosulfuric. No, not you don't get sulfuric acid. You get sulfurous acid because it's H2SO3, not H2SO4. So yeah, you get sulfurous, not sulfuric acid. So let's run this out. There's your aerosols. You can see it's actually kind of dipping down. So it's really diverging from what is it, from the observed. So no, it really is greenhouse gases. Atmospheric CO2 levels are 40% higher than they were in 1750. The amber line shows the influence of greenhouse gas emissions. No contest. So watch this graph. It's right there. So you have so what's going on here? Well, perhaps a little lag effect. You know, you're adding the CO2, the temperature might cool down a bit, and then it accumulates enough so it starts warming. Little lag effect, but again, starting from about late 60s, early mid 70s, wham! It just correlates very strongly. See for yourself. Greenhouse gases warm the atmosphere. Aerosols cool it a little bit. Ozone land use changes add and subtract. Together, they match the observed temperatures, particularly since 1950. So here we go. Land use. Here comes the ozone. Here comes the aerosol. Here comes the greenhouse gases. So now you can look at all of these taken together. So basically, the first composite graph was looking at natural factors. This second composite graph is human factors. Greenhouse gases takes the cake. And then here comes. Now we put all the human factors together and look at that. Just look how tight that is. Very good correlation there. So we're doing think of graphical addition, subtraction with the other factors here, and there you have it. So that one that just ran, the human factors, is basically the summation of these four other factors taken together. The greenhouse gas is the major contributor to that. So here, we're going to put the possible natural human causes of climate change alongside one another, makes the dominant role of greenhouse gases more plainly visible. The only real question is, what are we going to do about it? So we're looking at all four things against the observed. I mean, I think that's the end of this, isn't it? Yep. And it looks like yep, that was the end of that. So I wanted to show you, this is based on real data. So when someone tells you, oh, no, it's just natural cycles, whatever, you can say horse hockey. We have the evidence, the data that demonstrates quite clearly that humans are doing this. So again, you can go to the NASA website and look for these things here. Go to the GISS, the Goddard Institute Space Studies. on their website there. You will find these graphics there. So I just wanted to do this little presentation, kind of looking at natural factors, human factors, putting together, basically showing it's humans putting the greenhouse gases into the atmosphere that's creating the mess and everything that's happening as a result of that. So hope you found this informative, a bit entertaining, and thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.